Quantum entanglement. I need to understand a little bit of the physics here, because we did cover a little bit of quantum entanglement on Under the Microscope on other episodes featuring the quantum heroes. So please explain to me what exactly was happening. You'd already mentioned that there were these two quick pulses and going from the ground state to the excited state, and then before coming back to the ground state, you were exciting it again to go even higher.
Yeah.
Is that the ladder thing that Doris mentioned?
Similar to that, but even simpler.
Okay,
even
explain, please.
Okay, so imagine your atom. The first pulse brings you to the excited state. Okay?
Right.
Fine. You have not emitted any photons, you just have your atom in the excited state.
Let's say from 0 to 100.
Exactly. Yeah. Then you let the atom decay, which is going to decay. The physics law oblige it, so you will be decaying.
Right.
And while it is decaying, your atom is going to be entangled with the light field in which the atom is emitting. So you will be finding your atom in a situation in which either your atom is in the excited state and has emitted 0 photons because it has not decayed yet,
right,
or it has decayed to the ground state and then you have emitted 1 single photon. So this we write it as excited 0 plus ground 1. Okay, 0 and 1 is vacuum or single photon, and excited and ground is the state of the atom. So this composes an entangled state. If you know in which state your atom is, you will know how many photons it has emitted.
Correct.
This is entanglement. So while you are in this situation, you come with the next pulse. Okay, and the next pulse is going to affect the state of the atom.
I'm confused. Let's do it this way. So you mentioned 2 pulses, that I understand. Yeah, 2 pulses, ground state, excited state, that I also understand. For the emission of a single photon to happen, an atom has to go from 0, that is the ground state, to 1 to 0.
Yeah,
so 0, 1, 0.
Exactly. The laser puts you in the excited state,
right,
and then
correct.
the spontaneous emission will make you emit a single photon.
Right, that I understand. So now when the atom is 0 to 1, and then when it is coming down to 0, that is when your second pulse of light hits it. Maybe it is halfway, maybe it is one way, whatsoever. And then it is excited again, so it goes to, let's say, 1.5, 1.
Yeah. You flip basically the status of the atom. So if it was in this position, you will invert it, and if it was in this one, you will invert it.
What do you mean by inverting it? That I don't understand.
So it's making the ball, if the ball was in the ground state, you bring the ball up, and if it was up, the pulse brings your ball down. So if it brings it back to the ground state, it will not emit anything. This is why you will have vacuum in the end.
Okay.
You
it's flipping the coin, yeah?
Exactly.
So if I have the ball in my hand, which is in the ground state, and then I throw it to the first floor, and then while it is coming down from the first floor to the ground floor, your second light pulse is hitting it, and then it goes from the
whatever state it was, the opposite.
The opposite. But if it is at, let's say, 0.75.
Okay, I think you are thinking there with a classical mind.
Yes.
And you can't.
Oh.
So
okay.
the atom cannot be cannot be at 0.75. It is something that is either in one state or the. Then how much probability you will have to find the ball up or down, it will depend how much time you're waiting for the ball to decay.
Correct.
When I was explaining this whole experiment, I was simplifying it, mentioning that I will wait for a time in which I have the same probability of finding my ball in the excited state or in the ground state.
Right.
But if I wait a very long time, it will be most likely to find the ball in the ground state because it will have already decayed.
Right. And only emitted 1 photon.
Exactly. This is why here we are playing with the state of the atom, the state of the ball, up or down, I don't know where. But with the second pulse, I will rotate it, and it will affect the kind of light that will be emitted afterwards. It is entangled state.
So if the single photon is doing 0, 1, 0, and that's when you have 1 single photon, so what you're mentioning, it is like 0, 1, and then when it is hit by this other light bulbs, even if it is in 1, and if it is coming down to 0, then there would be this, oh, this is so cool.
It's a bit complicated. It took me a while to catch it up when my colleague Stephen was telling us about this possible explanation. But as soon as you write it, and then it becomes quite easy to follow.
Once you understand it, then you understand it.
Yeah.
I think I understood it, not entirely sure, but I think I understand it a bit better. I hope you enjoyed this snippet. You can listen to the full episode by following the link in the show notes. And if you are not following Under the Microscope already, please make sure to hit that follow button. It's absolutely for free, and it helps us grow the podcast even more. Thank you very much as always, and see you in the next one.